The global environment is steadily deteriorating. To help solve this issue, two scientists have laid out new guidelines for us. Professor Hans Schellnhuber is an authority on global warming countermeasures. If global temperatures continue to rise as they are doing now and go above a certain level, nature will start going out of control and major disasters could be caused. He points out this possibility.
And it turns out now that it is true. We have more and more evidence.
To avoid this, Professor Schellnhuber has put forward the importance of keeping the global average temperature rise well below 2 degrees centigrade compared to pre-industrial levels. His proposal has steered world political opinion, and in 2015, over 190 nations adopted the 2 degrees centigrade guardrail decided by the Paris Agreement. Professor Gretchen C of Stanford University has incorporated ecology and economics and showed that the blessings of nature have economic value.
The problem with saying it's priceless is that often nature measures up as having zero value in a cost-benefit type of world and framework of thinking.
Professor Daly has created a new benchmark so that a comparison can be made on an equal basis. For example, of the economic effect of a forest being developed or preserved. Her efforts have spread worldwide and are greatly influencing the decision-making of policymakers and investors. In 2017, the achievements of these two professors in helping to protect the future of the Earth were acknowledged. They were awarded the Blue Planet Prize, which is regarded as the Nobel Prize in the field of environmental issues. Every year, two major contributors to the solution of global environmental problems are selected as winners. They each receive a certificate of merit, a trophy, and 50 million yen. Exactly how did these two scientists present their new guidelines to the world? The Paris Agreement was adopted by many governments around the world in 2015. The significance of the agreement is to keep the increase in the global average temperature well below 2 degrees centigrade above pre-industrial levels. To achieve this, the demanding long-term goal of reducing CO2 emissions to virtually zero by the second half of this century was agreed by consensus. The Potsdam Institute for Climate Impact Research in Germany. The founding director, Professor Hans Schellnhuber, formed a theoretical foundation for the Paris Agreement. He predicted that there could be irreparable major disasters if global warming continues as it is now.
The Bay or the Tokyo, Yokohama region would just be flooded. It would just disappear. And when we have to steadily decline fairly quickly, and actually by 2040, 50, we have to get rid of emissions from industry and so on completely. Yeah? So that sounds dramatic, but it's the truth.
Professor Schellnhuber is basically a theoretical physicist who considers natural phenomena using mathematical simulations. The reason that drove him to get interested in the field of environmental issues that is different from his normal studies lies in his personal history. He was born in Bavaria, West Germany in 1950, not long after the end of World War II.
So we were pretty poor, I have to say, yeah, but on the other hand, I had a wonderful life because we were more or less surrounded by forests and fields and trees.
From an early age, he loved reading especially books about the universe and heavenly bodies, including science fiction.
I guess around the age of 10 or so on, I became interested in physics and things like that. So what is the universe made of? Why are the stars you see on the night sky like this and so on? And so together with my elder brother, who was 3.5 years my major, we stared at the sky, for example, and then started to read books about the planetary system.
He majored in physics at university and went on to take a doctoral course. Eager to conduct research that no one had done before, he was attracted to the leading-edge branch of contemporary physics called chaos theory. In the field of physics that unravels the laws hidden in nature, there was a mystery which had not been solved in those days. The shape of clouds and the flow of water. Phenomena in the natural world look chaotic at a glance. Chaos theory was a totally new branch of science for studying how those chaotic phenomena are generated and change. Karl von Ossietzky University, Oldenburg in northwestern Germany. In 1989, Professor Schellnhuber got deeply involved in various research projects using chaos theory.
He is a mathematical modeler, which for an institute doing science in the traditional way, he was a think tank by himself.
In those days, research on mudflats was actively being conducted at the university. As his contact with the natural world as a theoretical physicist grew, Professor Schellnhuber's interest in exploring its intricate phenomena using mathematics deepened.
The most complicated structures are in nature, actually. So my love for nature, which I always had from my childhood on, and my love for mathematical structures were also joined.
In 1992, immediately after East and West Germany were united, Professor Schellnhuber came to a turning point. He was appointed the founding director of PIK, the Potsdam Institute for Climate Impact Research. It was the first institute in the world to specialize in global warming studies by integrating a wide range of relevant research fields ranging from physics to economics. Up till then, research had mostly investigated the partial changes to nature caused by increased temperatures.
It was all about incremental change. 5% of change in wheat yield, for example. Malaria spreading by a few percent of the original area and so on. And I found this not only boring, I found it wrong-headed, ill-headed and wrong-headed. In a sense, shouldn't we think about the things we want to avoid by all means? Things that must not happen while we warm up the planet.
Professor Schellnhuber decided to adopt a broader perspective on global warming. What kind of disasters lie ahead if global warming continues to progress unchecked? It was the world's first effort to predict the future of the Earth through collaborative research. Experts from various fields, including geography, biology and economics, gathered around Professor Schellnhuber. Computer simulation methods were also employed. As the research proceeded, it became clear that if average global temperatures increase beyond a certain point, some natural systems will start exhibiting chaotic behavior that will dramatically change the environment.
So it would be bop. You go up the temperature scale, bop, 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 bop. Something like this. And with 4 or 5 or 6 degrees warming, you would run into a whole pack of major accidents. So in a way, my connection and my understanding of nonlinear dynamics made me able or enabled me to explore this research field.
In 2008, the map presented by Professor Schellnhuber and his research team caught the world's attention. It showed more than 10 natural systems at risk of creating large-scale disasters as global warming progresses and begins to run out of control.
And you can compare it in a way to the vital organs in a human body, you see, like the heart or the kidney and so on. If somebody puts a needle in your heart, you will die, actually. And that's precisely the same thing here. These are, if you like, the heart, the kidney, the lungs, the liver of the planet.
For example, as global warming continues to progress, the Greenland ice sheet will rapidly start to melt, and it will take at least 10,000 years to recover. If that happens, what kind of disasters could occur? It's related to the waters of the North Atlantic Ocean, which the Greenland ice sheet faces. In the North Atlantic, the seawater which flows north from areas close to the equator is gradually cooled and sinks into the deep water which forms the Atlantic Ocean current. This current generates warm atmospheric air and brings a mild climate to Europe.
Gulf Stream system. That's very important for Europe. Here in Europe we would have the climate of Alaska because we are on the same latitude, but it's much more mild and benign and warm.
However, when the fresh water melted from the Greenland ice sheet flows into the North Atlantic Ocean, the seawater is diluted and its power to sink is lost. Then the ocean current will stop. And the climate of Europe will grow cooler, and other phenomena may occur that have the possibility of threatening people's lives. To avoid this kind of climatic damage, Professor Schellnhuber and his research team pointed out the importance of keeping the increase in global average temperature to well below 2 degrees centigrade above pre-industrial levels. Since we entered the 21st century, we have been emitting around 30 billion tons of carbon dioxide every year. The limit we should not exceed is fast approaching.
We have a carbon budget left for humanity, probably about 600 billion tons of CO2. This is our credit left with nature. If we spend this credit and overspend it, then we will go beyond 2 degrees and we will enter a world which is incalculable, more or less.
Professor Schellnhuber continues to present this fact to politicians in a proactive way.
I mean, he's a scientist, but at the same time he knows how politics works. So he's not far away from what we're doing in our daily work. His advisors sometimes influence programs, influence government policies.
The long-term research about global warming by Professor Schellnhuber, the head of PIK, was widely acknowledged by politicians. And in 2015, he greatly contributed to the global community's adoption of the 2 degrees centigrade guardrail in the Paris Agreement. The global community has made a big step forward towards achieving a low-carbon society. The motivation of Professor Schellnhuber, who has been contributing to global warming countermeasures, is the existence of his 9-year-old son.
You must not fail your son, you must not fail your children, you must not fail the future generations. But ultimately I think it's an individual decision. But if you as a consumer make the right choice and you also try to lead a lifestyle that is less carbon intensive, when you set the standard for it, and even the biggest companies come down on their knees if they are deserted by their consumers. So I think the only way the world can be saved is through a global social movement, a social movement for climate protection. That's the ultimate dream.
There is another scientist who demonstrated a new guideline to help solve global environmental issues. Stanford University Professor Gretchen Daly's research has incorporated ecology and economics.
Hey.
She is one of the leading biologists in the field of nature conservation today. In 1997, she edited a collection of academic papers titled Nature Services: Societal Dependence on Natural Ecosystems. Professor Daly revealed that elucidating the economic value of nature is an effective means for nature conservation. In the 1990s, land development plans at New York City's water source promoted an issue of water pollution. The city had to make the decision of whether to build a water treatment facility or stop the land development and restore nature. Building a water treatment facility would require an initial investment of over $6 billion, and its service life would be 10 years. On the other hand, the cost of restoring nature would only require about $1.5 billion, and the effect of providing clean water would last for a long time. The city realized that nature could provide a value of at least $4.5 billion and decided to restore it.
In much of the world, there is no large habitat or wilderness anymore. So we have to engage in conservation right in the thick of human activity, where people are competing over land, over water, for a lot of different uses.
Born in 1964, Professor Daly grew up in California in the United States, surrounded by the bounties of nature. Her family moved to what was then West Germany when she was 12. She was shocked when she learned about the acid rain issue. It drove her to pursue a scientific path.
So as a young girl and teenager, first of all, I was amazed that something like acid could come out of the sky. I never heard of anything like that. And kill the forest and kill the lakes in Scandinavia and things. So I felt I should do something.
She enrolled in the Department of Biology at Stanford University and decided to pursue research on nature conservation. Under the guidance of Professor Paul Ehrlich, a leading authority in the field of biology, she studied the ways in which human activities affect nature.
Gretchen Daly is already the best environmental scientist in the world under the age of 60.
In 1995, Professor Daly carried out fieldwork in nature reserves in Costa Rica. While there, she had an inspiration. At that time, in order to preserve nature, it was thought that it was important for pristine nature to be protected and cut off from all human influences. Royal flycatchers were believed to inhabit only virgin rainforest, but Professor Daly happened to find them on farmland where people lived. she eventually came to think that there should be some way whereby people can live in harmony with nature.
And I couldn't believe how many different types of bird we found out on the farmland. So maybe, I don't know, I think about 170 species in that initial study. And I realized the farmland is habitat. And if you go and look at it that way, you actually see that there's a huge amount of nature, much more than people understood originally. And there's huge potential if we have that more complete understanding of where nature is and of how we can harmonize people living in, villages or on farms together with nature.
Convinced that not only pristine nature, but also nature in areas where people live, should be protected, she began to work in the interdisciplinary field she called countryside biogeography. There was a need to find a new means to protect nature, which is part of people's range of livelihood. She developed the idea that economic value should be placed on the blessings nature brings to people, such as clean water and stable weather, in order to protect them. She was guided by the late Kenneth Arrow, a Nobel laureate in economic sciences. He was engaged in research to adopt nature into the economic system.
Nature has always been measured as either being priceless, having so much value, and a type of value that is spiritual or otherwise very deep and not expressible in terms of a price in a meaningful way. So we say priceless, or it's had zero value. The problem with saying it's priceless is that often nature measures up as having zero value in a cost-benefit type of world and framework of thinking. So we wanted to confront that world first and say, actually, nature has a lot of value.
In 2006, Professor Daly launched a project to put her idea into practice. In collaboration with various experts and students, she started working on research which elucidates the economic values of natural resources. And in 2008, the team unveiled a software system called INVEST. It maps the location of natural resources which provide economic value, including water purification and CO2 absorption. What economic benefits can be expected if investment in nature is carried out? The team created software that can help anyone make the calculations. INVEST was applied first on Oahu Island in Hawaii. The team advised a private institution on how it should invest in an area of 10,000 hectares called Kauai Loa. On the assumption that Kauai Loa had three possible business scenarios: biofuels, housing, and agriculture and forestry, the project team mapped the economic value of the natural resources and the income that would be generated by development. INVEST shows green when the economic value increases and red when the value decreases. The housing scenario, which can expect the most income, is shown as dark green. However, biofuels and housing show red regarding water quality. That means the economic loss due to deterioration of water quality is big. As a result of several surveys, INVEST indicated that the most balanced profit without destroying the environment could be expected from agriculture and forestry. Learning from this result, the institution, which attached great importance to the balance between nature and profit, chose to invest in the management of diversified farming and forestry. The project team was successful in contributing to nature conservation by having shown the value of the natural ecosystem. The idea that investments in nature have economic value is now influencing the business community.
Here to talk about nature and markets, we have three guests.
Companies and investors who up to now have not been involved in environmental issues are beginning to turn to nature conservation.
Basically, before this understanding, there were only really two ways to make money from land. What Gretchen Daly understood and began to articulate is that there's actually a third way that land is valuable. There's building on it, taking from it, and then what it does for us when we protect it and manage it. So it gives us clean water, a stable climate, and resilient living systems. And so by understanding and measuring the values that are produced by the forest or the wetland or the stream or the ocean, you begin to be able to pay that person to leave the trees standing, to manage that system. And that's the breakthrough that Gretchen is part of.
The project has already been applied in around 50 countries. Since 2012, at the request of the Chinese government, Professor Daly has been energetically involved in activities concerned with nature conservation in the whole of China.
Yeah, we need energy, we need food. There are a lot of needs we have, but how do we balance those needs with the planet's needs? We need the planet more than anything.
Okay.
The Blue Planet Prize in 2017 was awarded to the physicist Schellnhuber and the biologist Gretchen Daly for their contributions to solving global environmental issues. The Blue Planet Prize has a history of 25 years. Thanks to the results of the research achieved by the prize winners, methods for environmental protection have steadily been evolving. On the other hand, however, the measures are still far from adequate to save the Earth for the future.
Man-made climate change has roared on, since policy has largely failed us. Our planet has already warmed by roughly 1 degree centigrade. A great transformation of the global economy will be required to hold this line of defense against climate chaos.
So investing in nature must become fundamental in the realms of government, of business, finance, and communities. We need heroes. The heroism does exist to transform the world, to create new mindsets and institutions for green and inclusive growth.
We all shoulder the responsibility of how to make the best use of the new guidelines presented by the two scientists. This program was made possible by the Asahi Glass Foundation.